Okay, we're going to take a look at graphing quadratics in intercept form. Uh, Intercept form is represented by this equation where we have f at x, which, don't forget, just means y, equals a times a quantity x minus r1 times a quantity x minus r2. Okay, so we're going to graph this one, for example. And then what we're going to do is rewrite it just so it's a little easier to identify one piece of it. Y equals 2 times the quantity x minus 1 times the quantity x. This is the part I'm going to adjust here. Minus negative 3. Okay, we want to do that because don't forget this equation up here calls for the two quantities to be differences. Okay, not sums. So from there, we can pretty readily identify the critical parts. We're going to get a equals 2, r1 equals 1, and r2 equals negative 3. Okay, we've got the problem in a place where we're ready to attack it now, in earnest. So, why is it called intercept form? Well, it's because they're the easy things to be able to grab up quickly when it's written in this form. Okay, and those are going to be r1 and r2. Okay, they're the x-intercepts, so we get 1 and negative 3. It makes sense to even maybe try and just plot those right now. So as this graph comes together, we'll see the pieces kind of fit. Okay, now let's look down here. We've got a couple of things we got to strategize around. The y-intercept, when we hear y-intercept, we want to think x is 0. And then you just plug that in and chug it out to get y. The vertex we're going to need a formula for, as well as the axis of symmetry, and don't forget they are related. The axis of symmetry is going to be of the form x equals, the axis of symmetry is a line, okay? Then we're going to use that x down here in the vertex. Okay, so let's get to work and take a look at that. I guess the first thing we could do is probably get the y-intercept. It shouldn't be too hard. And I'm going to take a look at that right here. So for the y-intercept, we talk about x equals 0. Well, if x equals 0, y will be 2 times the quantity of 0 minus 1 times the quantity of 0 plus 3. The only thing I did was plug 0 in for x in the original equation, and now I'm simplifying. So we get 2 times negative 1 times 3 equals negative 6. Okay? So we see that the y-intercept is negative 6. And I will now graph that. Okay? No matter what form you're working in, when you hear y-intercept, you got to say x equals 0. Okay? So, now let's take a look at the axis of symmetry. Well, since I know the axis of symmetry is going to be between those two x-intercepts, it makes sense to think that you could average those two x-intercepts. So that would mean something like this. Okay? So if you average the two x-intercepts, you're going to get the axis of symmetry. Okay, so let's take a look at that. This is equal to 1 plus negative 3 over 2, which is equal to negative 2 over 2 is equal to negative 1. Okay? So that means that we've got x equals negative 1 is our axis of symmetry. And that is going to look like a dotted line that goes right down the graph at x equals negative 1. Okay, so now that I know that that's the x value, I could take a second and probably just write it here. X equals -1 is the equation of that line. Okay, if I were going to continue with that, well, how could I find the vertex? Well, I know the vertex is somewhere on this line, so I know its x value. And once again, once you know an x value for a function, you could find its y value by just plugging it in. So let's plug in -1 and go 2 times a quantity, -1 minus 1 times a quantity, -1 plus 3. Now that's going to be equal to 2 times -2 times 2, which is going to give us -8. So that means the vertex is going to be -1 for the x value, okay, and -8 for the y value, sometimes referred to by Mrs. Brewa as h comma k for a sense of consistency around, like for example, if you were graphing something in vertex form. But don't forget, the h comma k is a point. It's really x comma y, okay? And then we can graph that point and say -1 comma -8. Okay. Now, if you want to be fancy schmancy, what you could do is realize that there's a point reflected over the y-intercept. You can see here that the y-intercept is one grid away from the axis of symmetry, so there must be, by symmetry, another point on the graph that is just one grid on the other side. So if you wanted to connect the dots, I'm not real good at this using my slate. Well, this turned out okay. This is going to be your graph. Okay? So feel free to replay that a couple times and enjoy.